Today we're going to take a look at being able to simplify and also solve rational expressions and equations. Those are our main targets, but we have to be able to work with them completely. Any of these types of addition, subtraction, multiplication, division of rational expressions we have to be able to do. We have to make sure we can solve them and a lot of different variations in them as well. So within this video, we're going to see a couple examples of each. So we should get comfortable and familiar with how to work with them. Now, the biggest thing about simplifying a rational expression and recognizing the fraction that you have there is understanding when you can and cannot just cross something off. Okay, we can simplify rational expressions vertically because anything divided by itself is 1. But it doesn't mean we can just cross off those sevens because, oh, I got a 7 and a 7. 7 divided by 7 is 1. You can't just cross them off. It wouldn't stay to be an equivalent value. The biggest way that I can see this in action is taking a look at concrete numbers, where you can actually see 1 plus 3 over 3. Well, I know 1 plus 3 over 3 is 4/3. It is not just 1. Or let's say you wanted to call it 1 over 1. It is not 2 over 1. So it's definitely not equivalent just to cross those off. But I do know this, 1 times 3 over 3, that is equivalent to 3/3, which is 1. And notice what happens. Cross those off and it is just 1. That's because it was separated by multiplication. So whenever you have terms separated by multiplication, then you can simplify vertically. Because if you're multiplying, the division is what will undo it, right? So I can't cross these off. What you could do is factor though, x plus 7, x plus 1, all over x plus 7. And now you notice you've got a product of two things up here divided by one quantity. Those now can be reduced. And your simplified form is x plus 1. So there is simplifying we can do, but you got to remember to factor first. And that kind of gets into our questions of addition, subtraction, multiplication, and so on. So I just have one subtraction, one multiplication here on this page. But what we do for subtraction, you do for addition. What you do for multiplication, you do for division. But you just have to remember with with division, you multiply by the reciprocal. So you flip the second fraction, whatever you're dividing by. So let's start with subtraction here. Well, in order to subtract just standard numbers, you need common denominators. So let's make that happen. Let's factor first. Let's see what we're working with. 8 and -2, 3 over x plus 8. So if this one has an x plus 8 and a -2, that means this one over here needs an x minus 2. Remember, they need what they don't have. So then you got to make sure you be very careful with this distribution. You need to multiply in not only this 3, this -3, if you want to combine it all in one step right away. So this becomes 2x and then minus 3x plus 6, all divided by x plus 8 and x minus 2. Just to simplify a little bit further, -x plus 6 all over x plus 8, x minus 2. So you got to be careful with the negatives here in these problems. This right here, this right side is where the most amount of mistakes will come in. The next one with multiplication, you can't just start crossing stuff off. And I would highly suggest you don't begin distribution. That would get you way further from where you want to go. So we want to factor. Let's see if there's common factors we could cross off. So we got a 4 and a 2 on this one. On the denominator here, you could take out a 2. Okay. This one is a 5 and a 2. 5 and a -2. And this one is an x plus 4. So we can simplify vertically within our fraction or across diagonally, but you can only do 2 at a time. So let's see here. This x minus 2, now that everything's multiplication, start crossing off, start simplifying, dividing them, turning it into 1. Cross off those x minus 2s, cross off, simplify, and reduce those x plus 4s, and our final answer, you just kind of smush it all together. It would just be x plus 2, x plus 5 all over 2. And that would be our final simplified form of the answer. Now, if you want to distribute the top, feel free. You just don't have to. Our last simplifying question is going to be called simplifying a complex fraction. So that's when you have a fraction within a fraction. And there's a couple ways to do this, but one of the best ways I would say is to just combine the two up top, add those, combine the two on the bottom, add those up, and then you could do the division, which we can see in a second makes it a little bit cleaner. So if we were to add these two up top, we have an x and a y. They need a common denominator. This needs a y. This needs an x. So we're doing them individually here, okay? Top and bottom individually. X, y, that means this needs an x. And you create them through multiplication. So let's go to the next step. So this becomes y, now that they're a common denominator, y plus x over xy, all divided by, this is that's an xy, 1 plus x squared, all divided by xy. Now from here, if we have a division problem, that's what this is. We've got a fraction divided by a fraction. So what you can do is you could say y plus x over xy. Instead of division, multiply by its reciprocal, xy over 1 plus x squared. Notice how this is one quantity because it's separated by addition, but these are separated by multiplication, so you can actually reduce those. That can get simplified. Y plus x over 1 plus x squared. And that would be as far as you can go with simplifying that one. So a fraction in a fraction or a complex fraction, I think it's usually easiest just to add up the top, add up the bottom, and then multiply by the reciprocal. Final two questions of the day. We're going to look at solving. Now, there's a couple ways to solve. One way to solve is to cross multiply. That's what I would do in this scenario. This one is like perfectly set up for cross multiplication. I see a single fraction equals a single fraction. So let's multiply across and set that equal to each other. 4 times x minus 2 equals 1 times 3x plus 2. And I know there's some things I could have done the distribution in my head, but just kind of writing out that step. 4x minus 8 is then equal to 3x plus 2. Now let's solve this equation. Subtract 3x, add 8, and x is 10. We could plug it in and check it, and we would see that the two sides would be equivalent. Now, if we look at our final question here today, this one has a whole lot more going on. We've got options here in terms of how you want to solve it. You can choose to add these two together, combine it, make it one fraction, and then you could do cross multiplication. But sometimes that could give us what's referred to as extraneous solutions if you just jump to cross multiplication. And that's a solution that actually makes you divide by 0. So for example, x equals 3, that could never be a solution because that would give us 1 over 0. Not possible. That's what extraneous solutions mean. So you could add them, and that's not bad to do. You could still get to the correct answers. But what could be easier sometimes is just to make them all the same denominator and then get rid of that denominator. And here's what I mean by that. If you were to factor this, minus 3 plus 2 plus 1 over x plus 2 equals 1 over x minus 3. If you decided to just do this one needs an x minus 3. This one needs an x plus 2. You could then use this property. Think about what we do for a basic equation. X over 2 equals 4. Well, if I'm dividing by 2, how do you get rid of that, right? You're trying to solve this. So think about just a completely separate example for a second. X divided by 2 equals 4. Well, if that's being divided, I could multiply both sides by 2, and notice what happens. It goes away. And then you can continue your solving process. So we are currently dividing everything by what you see here. So what we could do instead is we could multiply both sides by the common denominator, and that way we could get rid of that fraction that we have. So if we do x minus 3 times x plus 2, and we multiply it on both sides of this equation, what we're going to notice is that the denominator goes away, just like it did in this very basic example. So once we do that, we can then simplify, and that all goes away. So we're left with a very basic equation that looks like this, which is something we can handle in the solving process. So if we were to continue through solving this, let's see what happens. Well, if I subtract x over there, we get those to cancel. This is 2 equals 2. So the question is, what does that mean? That's not normal. Shouldn't we get like x equals a number? Yes, we should. But what we got is a true statement, 2 equals 2. What that tells me is that it does not matter what x is, x could be any single number you want, and it would make this equation true. Okay, it would make the equation true. So that's one way of referring to that is, let me clear some space, the solutions, x can be, that stands for all real numbers. All real numbers. But we do have to clarify something. There are two numbers that it cannot be. And hopefully you guys see what those two numbers are. It cannot be -2 or 3 because it would have made our denominator divide by 0, which is extraneous. So just to be clear, when you do this process, this is not the norm. Okay, you're not always going to get just, oh, the x's went away. All real numbers or no solution. I can't solve it. You're usually going to get a number, but this is just one scenario showing that that can happen. What does that answer look like? And then make sure you state what it can never be in that scenario. All right, that's it for this video.